Hello, thank you for joining Teacher Saviour today, and we will look at earth geometry. And under earth geometry, we will look at calculating time and the speed. Okay, let's go straight into business. We look at how to calculate time. That's the first thing that we will start with. The first thing you have to take note is that time is calculated using longitudes. So the difference, the longitudes, the difference, the time is if two towns or places, any place, if two places are at different sides of the longitudes, or if the longitudes are different, then the time, meaning the time will be different. But if the two places or points are at the same, they are lying on the same longitude, meaning the time will be the same. So time is calculated in longitudes because the longitudes are the one that determines the difference in time. Then the next thing to take note here is that the earth rotates at 15 degrees per hour. 15 degrees per hour. Then the other thing is that when you're calculating the time difference between 2 points, simply first find the difference in longitudes and then divide by 3, which gives us this simple formula. Time difference is equal to theta over 15 degrees. We have borrowed theta to represent the angle difference or the difference in the longitudes. Then after finding the time difference, you have to check if the point which you are finding time for is to the east side of the original place or to the west. So time due east is gained. It is gained. You add the difference which you have found the time to the time which you are given at the point. If it's going toward east, you add. That means it is gained. Then time due west is lost as you go to the west side. As if when you are finding time to at the point which is to the west side, you subtract from the original time given at the point. Okay, so these are some of the points that you need to consider when you are calculating time under earth geometry. Before we do an example, let's also look at the speed, how to calculate for speed under earth geometry. What you have to know is that speed is calculated in knots and kilometers per hour, and if distance is in nautical miles and time in hours, then the units of speed are knots. So the distance and the hour, the time, we're determining the units for speed. Then the next point, if the distance is in kilometers and time in hours, then the units of speed will be kilometer per hour. And here we have the formula, speed which is equal to distance over time. So what we determine is the distance, if it is in nautical miles or kilometers, then it will give you the units for speed. Okay, let us now look at this example, which I've gotten it from exam past paper 2019, paper 1 internal. Okay, the diagram below shows the points A, B, and C on Earth's surface. Question A, if it is 08:20 hours at A, what time is it at C? Question B, a plane flies from A to B at a speed of 400 knots. How long does the journey take if AB is equal to 4,800 knots? Now let's look at the solutions to the two questions that we have. And for the first question, it's saying if it is 0:20 hours at A, what is it at C? Here they're asking you to find the time at C if it is 0:20 at A. So now let's check for the longitudes for A and C. The longitudes for A and C. So A is here. The longitude for A we have is 20 degrees east. Then we also have the longitude for C, point C, which is here. Then the longitude is here. In this case here, you can see that they are all on the same side. They are at the east side. Yeah, that's one thing you have to take note. They are at the same side. Since C is at 95 degrees east and A is at 20 degrees east. So to start solving this, we'll first find the angular distance difference, or the difference in longitudes between A and C. Since we said time is calculated using longitudes. So in this case, let's find the time difference. Okay. Let's find time difference, which will be using that formula of theta is the one which we are going to use to represent for the distance. The distance between A and B, or the difference, the angle, which is the angular difference, over 15. Okay, so remember we said 15 represents the degrees at which the earth rotates per hour. Per hour, the earth rotates at 15 degrees. If we get back to A and C, we have the longitude at A, which is 20 degrees east, and at C, 95 degrees east. So if you have two longitudes lying at the same side, it means to find the difference, you have to subtract. And if they are lying at different sides, the longitudes, you have to add. So in this case, they are all lying at the east side, 20 degrees east and 95 degrees east. We are going to subtract. So 95 minus 20, we are getting 75. So here we have 75 as our difference over 15. Okay, so 75 divided by 15, we are getting 5. So this 5 we have gotten. These are the hours. This is the time difference. This is the time difference between point A and the point C. 5 hours. So this is not our final answer. Remember, we are calculating the time at C. If at A it is 8:20 hours. So now the next thing to calculate, to take note, so you say therefore the time will be equal to check if point C is to the east side of A or is to the west side of A. And if you check here, we can see that point C is going to the east side of A, and we say time due east is gained, or time due west is lost. We are going to get a time for A, which is 08, okay, 0820, 0820, okay, plus the difference, which is 5. So in this case we are going to say 05 hours plus 05 hours, because the time is going, we are moving towards the east of A, that's why we are adding in this case. And if you add in this case, you get that is 80 plus 5 hours, we'll get 1320 hours. Okay, 1320 hours. So that's the time at C. If it is 820 at A, then at C it will be 1320. Now let's move on to the next question. To the plane flies from A to B at a speed of 400 knots. How long does the journey take? If AB is equal to 4,800 nautical miles. So we have the data here. You can see that the speed is 400 knots, distance 4,800 nautical miles. In this case, we are looking for time, is what is missing. Let's introduce the formula. So speed is equal to distance over time. Okay, so we have our speed here. Our speed is 400. Okay, 400 knots. We are replacing now. Okay, then our distance is 4,000. Distance is 4,800 nautical miles. So remember, it is in nautical miles, then over time. So T is time. In this case, we are going to cross multiplication sign, meaning you multiply now, and when you cross multiplication, the multiplication sign, we are going to have 400 times T, you get 400 T equal to, when you multiply 1 multiplied by 4,800, remember 400 here, there it's the same as 400 over 1. 400 over 1. Okay. Then to make a t the subject of the formula, you're going to divide both sides. Divide by 400. Okay. Okay, we divide by 400. So here we are remaining when you cancel, when you divide, simply this means this will be cancelled. It means you have divided. It is 400 into 400, that's 1. Then you remain with t there. So here we have t, okay, which is equal to, and then there, to simplify things, and since this question is coming from paper 1, and paper 1 you are not advised to use a calculator. Calculator is not needed at all. You cancel the zeros, then you can just divide 4 into 48, whereby you get 12. So our time is 12, meaning this plane flew in 12 hours. In 12 hours, that's the time it spent. So this is our final answer for question B. So this is how you calculate time and distance. You can try to solve some more questions on how to calculate for time and distance. In one of the lessons, I'll do on paper 2 type of questions on earth geometry, on how to calculate the difference and speed in small circles and the great circles. So for this type of question, this is how you work it out. Okay, thank you very much for your attention. Make sure that you subscribe so that you can receive anytime I post a new video. So subscribe to get a notification, like and comment in the comment section. If you have any question or any contribution, you can comment in the comment section. Bye bye.